Dear students, welcome to all to the circular knitting technology course. Today's session we will discuss about main components of single bed knitting machines. That is single bed circular knitting machines we will discuss today's session. And in the last sessions or previous sessions we have discussed about the classification criteria and complete classification of knitting machines as per the diameter and needle bed concern, and large diameter circular knitting machines and what is the structure of large diameter circular knitting machines, and along with that we have seen that yarn feeding systems in the circular knitting technology. So today's session we will brief about or discuss about main components of single bed knitting machines, that too single bed circular weft knitting machines. So what is exactly the knitting bed is having? So the knitting head is having, so you can see here, this is the head of the knitting machine. So head of the knitting machine nothing but, already in the previous sessions I told, there is a needle base or needle bed. So needle bed or the bed where the knitting elements are there. So knitting elements nothing but, as I already told, cylinder, needles, sinkers, cams are the knitting elements. So that too we are discussing about only single bed circular knitting machines. Single bed circular knitting machine nothing but only one cylinder is present in the knitting machine. So we can only make single jersey fabrics in the circular knitting machine, that too single bed circular knitting machines. So we will discuss one by one what is exactly and what are the different elements which are present in the single bed weft knitting machines. Now again, to remember, we have a creels. The creel is nothing but, creels are the knitting elements which carry the yarn packages to feed into the knitting zone. The number of feeders in the knitting machine is equal to the number of cones of the creel. So nothing but, as we have already seen, the number of packages are directly proportional to the number of feeders. Nothing but, if we have 90 number of feeders, 90 number of weft packages are required in the weft knitting machine. So reserve cones also will be available, or reserve cones will be present in the beside of the creel. So whenever the exhaust packages are there, it can be, whenever the exhaust package is there, they will remove and they will replace the new packages into the creel section. Now this is the one type of creel, as I already discussed what is exactly the top creel is. So the top of the machine we have a creel section. In the creel we have a pegs. On the pegs we are going to mount the packages on the creel section. So from these the yarn is going to be fed to the yarn feeders to the yarn guides. So this is how the yarn is going to be fed into the next or knitting elements. Now this is the side creel. We have already discussed what is exactly the side creel or lateral creel is. Now the major element in the knitting process or in the single knitting or single bed knitting machines is, one is called as the needle. So the needle is nothing but, it is a hooked metal needle, is principal knitting element of the knitting machine. So without the needle we cannot able to manufacture the knitted cloth, or we cannot able to make the loop in the knitting process. So that is why it is a key element. Without the needle we cannot able to manufacture the fabric. And prior to the yarn feeding, the needle is raised to clear the old loop from the hook and to receive the new loop and above it on the needle stem. Nothing but, in the last session we have discussed about the loop formation sequence of latch needle, spring-borded needle and the compound needle. So specifically in single bed weft knitting machines, we are generally used as a latch needle. So there are 5 steps in the loop formation sequence. One is called as the running position and clearing position, feeding, knocking over and loop pulling positions. These are the 5 basic positions or basic sequences of loop formation of a latch needle is. And the new loop is then enclosed, and that is the sequence how the new loop is going to be made by using the needle. And so this latch needle is a self-acting needle. Why we are calling it is self-acting needle is because the latch is closes automatically nothing but with the help of old loop. Opening and closing can be done with the help of old loop. That is why the latch needle is called as self-acting needle. And the next we can see here there are images of the latch needle and how this hook part and the latch parts are present and where is the butt position, and you can observe the butt positions of the needle. And you can see here in the last diagram where the needle is present or the needle is inserted in the cylinder and the butt position is projected outside from the circular bed or cylinder. So the next element is sinker. So sinker is a thin metal plate with action at right angles to and fro between the adjoining needles. So sinker is a thin metal plate which is going to be activated, or the action of the sinker is right angles to the needle. So nothing but the to and fro of the sinker is there. So why this sinker is used? It is performing some functions that is called as loop formation, holding down and knocking over. So for these 3 operations the sinker is going to be very, very important, and this sinker is going to function for all these 3 areas. Now what is the main objective of this sinker is to assist the needle in loop formation by sinking or knitting the newly laid yarn onto a loop. So as its forward edges of the catch advantage between the 2 adjoining needles. Simple terms, what is the main objective is when the already formed loops are there. So what is the action of the needle is? Action of the needle is rising up and lowering down. For example, if we have a needle which is having the old loop, if the needle is rising up, what will happen? The loop is under tension. So because of the contact between the yarn and the needle, so along with the needle, the yarn or loop is going to be raised up. So we do not want to raise the old loop along with the needle. So that is our main concern. So what is the main objective of this sinker is? The sinker is going to hold down the old loop so that when the needle is rising up, it will not rise the old loops along with the needle. So once again I am telling, so the sinker is going to assist or hold down the needle, hold down the old loop so that when the needle is rising up, along with the needle, old loop cannot be raised up. This is the major objective of the sinker. You can see here the sinker parts where these are the different types of sinkers. This is generally depends upon the gauge of the machine and how many number of needles per 1 inch it is available. So and the cylinder circumference, accordingly the sinker dimensions are going to be varied. And you can observe here there are different parts in the sinker. You can see that what is a sinker and what are these parts are. So whatever this throat part is there, the throat angle, so this throat part is going to hold on the old loops so that the old loop should not be raised along with the needle when the needle is rising up. So this is the main objective of this sinker. Now we will see that what and how exactly this sinker is operation. Nothing but how this sinker is going to be operated and what are these different steps. There are basically 5 steps in the sinker operation. So the first step, you can observe the first image. The held loop is positioned in the throat of the sinker when the sinker moves forward and the needle moves upward. So simply you can understand by seeing the image, the sinker is moving forward and it is holding the old loops which are already formed when the needle is rising up. So this is the first position, and you can see that the second position remains, the sinker is going to be hold on onto the old loops, and you can observe the position of the needle here. So the needle is again it is rising up. So nothing but in the first step to the second step, sinker is still it is holds the old loop and the needle is rising up. So that is the second point. Now the third position, what is happening is now after complete clearing of the needle, when the yarn is feeding, that time, so completely it was raised up, so sinker is not required. So at that time the sinker is going to be retracted, nothing but it is going back to its original position. So after the yarn feeding, the needle is going to be raised up. That is the third step. You can see that the sinker retracts when the needle comes down after feeding. So at this stage, due to sinker retraction, fabric or held loop is eased out. Also, the sinker belly supported the fabric or held loops, and hence its movement along the needle is prevented. Nothing but if the sinker is moving back also, because of the sinker part which is available, so it will be belly part. The belly part is going to be supported the fabric. So in that case the fabric is supported by the belly. And again when in the fourth case, again the sinker remains in the same backward position and the needle is lowering down, that is knocking over, and through the old loop new loop is forming. So still the sinker belly is supported the old loops. That is the fourth stage. So after fourth stage, you can see that again it is going to be activated towards the forward action, towards the old loop, because the next step is again the needle is going to be raised up to take the new yarn. So that is the 5 steps. So again, once again, what are the different steps? First step, sinker is activated when the needle is rising. Second step, sinker is activated still the needle is rising. And third part, sinker is going back when the needle is lowering down. And in the fourth stage, sinker is gone back and the needle is still pulling the yarn so that the new loop is forming. And after loop formation, again the sinker started to move forward. So these are the different operations of the sinker generally. So I think it is clear to you. So there are 5 operations of the sinker. So sinker is the major part. So whenever the needle is rising up and lowering down, so the sinker part is going to assist the old loops to do not rise up along with the needle, to do not lower down the loops into the bottom of the knitting machine. So that is the major thing. And the next element is a cylinder. So what is exactly the cylinder is? Cylinder is a steel circular bed having a grooves, trikes or cuts, that we are talking about trikes or slots. Outer periphery, nothing but the cylinder is there, and at the outer periphery of the cylinder we have a trikes or cuts. So in the trikes or cuts we can mount the needles. So these are the trikes. So trikes are vertically slitted. Okay, so vertically slitted, so that the needle when it engages in the trike of the cylinder, so it can operate by up and down motion. So that is the major part. So this is the thing, one of the element, major element, cylinder. Okay. So the number of trikes per 1 inch, that is number of needles per inch, decided to the gauge of the machine. So nothing but decided by the gauge of the machine. If the gauge of the machine is more, obviously the needles per 1 inch should be more. For example, if we have 25 gauge, 25 number of needles should be accommodated in 1 inch. Nothing but, if you have seen the cylinder outer periphery, if you count the number of trikes or slots, so the slots should be, if the gauge is 25, 25 number of slots should be there in 1 inch of the length of the cylinder circumference. So that is the major part. So if you want to increase the more gauge, or gauge if you want to increase 25 to 30, so automatically we need to change the cylinder, then only it is possible, because the cylinder cannot be adjustable, the tracks cannot be adjustable. So that is the major thing. So you can see here I have given the part, wedge part and the trike. So in the trike we have a needle. So if you see the overall picture, the cylinder, outer periphery of the cylinder, there are trikes. In the trikes there is a needle. So this is how the needle is mount on the cylinder, trikes. Now you also observe, if you observe the needle butt, so needle butt is projected outside the surface of outside. So nothing but towards the outside the butt is projected. So when we can put the cam, so that if the cylinder is rotating, along with the cylinder, needle is also going to rotate, but the butt is going to follow the cam track, so that the needle is going to rise up and lower down. So this is how it is going to be happen. So needle is placed and the butt will be projected outside of the cylinder. So this is how the needle is going to be mounted. So you can see the overall picture of here, the cylinder and how these courses and valves or number of needles are present in the circular single bed circular weft knitting machine. Then the next element is cams. The knitting cams are harder steels and they are assembled different cam plates so that the track or butt can be arranged. So nothing but it's a metallic part which is having a groove. Okay. So if it is a straight line groove, then if the butt is positioned and butt of the needle is positioned, so once the cylinder is rotating, along with the cylinder, needle also going to rotate. So the needle butt is going to inside the cam track, so that it will follow the cam track. For example, if the cam track is like a vertical, now the butt is going to be move or follow the cam track. So butt of the needle is going to move or follow the cam track. So whether it is straight, nothing but the butt of the needle is going to follow, that is running position. If it is clearing position, and we will see that what are the different types of stitches we can make by using different types of cams. Now you can see the picture of the cams which are here presenting, like knit cams, tuck cams, and you can also observe the miss cam or run-in cam. So what is exactly the different types of cam parts we are using and how this needle is going to be moved? Here we can see there are cam parts like run-in cam, guard cam, clearing cam, stitch cam or adjustable cam. So the stitch cam or adjustable cam is directly influencing your loop length in the knitted fabric structure. Next one is up through cam. So after the needle butt is passing through the run-in cam, then needle is going to be raised up with the help of clearing cam, because the angle of the clearing cam groove is like an angular motion, so that when the needle along with the cylinder needle is moving, So the needle is going to follow the cam track. Nothing but needle butt is going to follow the cam track. If the cam track is straight, it will go straightly. If it is having an angular motion, so it will go up and down, nothing but up and down. So depends upon this clearing cam and stitch cam, the needle is going to be raised up and lower down. So clearing cam is going to help the needle to rise up, and stitch cam is going to be help the needle to lower down. So if the adjustable cam or stitch cam, if we have a depth, nothing but loop pulling will be more and more. Nothing but if we are lowering down, nothing but more lowering down or knocking over, it is more. Nothing but the needle is pulling more. So needle pulling more, nothing but after the newly yarn fed to the hook, so the loop length is going to be increased. So after the loop formation, it is going into the up through cam and running, then it is going to be continue. So you can see that the top image of this is direction of the needle travel and how this running, clearing, feeding, yarn feeding nothing but yarn feeding, and knocking over and loop pulling and running. So these are the different types of cam parts we are using in the knitting machine. Now we can also form with the help of different type of cams. We can also make different type of stitches. So completely loop, without loop, tuck. So there are three different types of stitches are there: knit stitch, tuck stitch and miss stitch. These are the three different types of stitches generally used in the knitting machine. So now these stitches can be made by adjusting the cam. So you can see that there is a swing cam. If the swing cam, the path is equal to the running path, then it is called as miss. There is no rising up of the needle. For example, if we have this swing cam, swing part, if we rise up certain level, but there is no yarn clearing through the latch, so that there is no clearing of the loop is occurred, so we are again feeding the yarn along with the old loop, so it will form the tuck stitch. If we completely raised up, nothing but loop is cleared and we are feeding the yarn to the needle hook, then we are making the new loop through the old loop. So this is called as knit stitch. These three types of stitches can be made by adjusting the cam settings or by using the different types of cams. You can see here the cams are, I told the cylinder. In the cylinder tracks we can mount the needles. Needle butts will be projected outside the cylinder, and towards the cylinder butts we can fix the cams. So these are the cams, just they are open and showing the cam tracks. This is specifically multi cam track system. There are multiple cam tracks are there, 1 2 3 4 cam tracks are there. You can see here the multi cam track system. So in this case, so the butt positions of the needles are going to be different. So 4 different positions of the butt will be there. So that we will discuss in the further sessions. And the next one is fabric spreader. What is exactly the fabric spreader is? After the loop formation, nothing but the fabric is going to be made. Then this fabric need to be spreaded, because there should not be any wrinkles or creases. So if the wrinkles or creases are formed and it is winding into the cloth roller, and it will become like a permanent mark. So it should not be there. So that is why we should have a fabric spreader. So what is the fabric spreader is? In circular knitting, the tubular fabric descends from the needles is converged into flattened double layer. Flattened double layer. It is a tubular fabric, but it will be flattened into a double layer and rolled into the yard goods, nothing but the fabric. During such conversion, irregular tensions are going to be developed throughout the fabric due to distance variations which leads to unwanted wrinkles or crease marks and stitch deformations. So these wrinkles, crease marks and the stitch deformations are, if it is occurred at the time of fabric takedown and winding, then it becomes a very permanent, nothing but permanent marks are going to be happen. So it cannot be removed. It is very difficult to remove in the further process, that is chemical processing area. So that is why we should have a fabric spreader. So they can be only removed with great difficulty during that, what I have discussed is in the finishing stages. So it is difficult to remove if it is occurred. So that is one of the drawback. So because of that, we required a fabric spreader to spread the fabric uniformly. So you can see here what is exactly the spreader is. So spreader is like inside the tubular fabric there will be spring type, like supportive metal parts will be there, so that the fabric is evenly spread. Then through the takedown rollers, the fabric, that compressed fabric or double layer tubular fabric is going to be winded into the cloth roller. Or else sometimes after tubular, this is also the same spreading mechanism. You can see here the spreading of the fabric, and sometimes after this spreading you can have the cutter. So this tubular fabric can be cut in the vertical manner, nothing but in the while producing itself you can cut and you can flatten the fabric and you can wind into the cloth roller. So that is also can be possible in case of circular knitting machines with the spreading. So spreading nothing but it should remove the creases and wrinkles and stitch deformations while the fabric making process. Now the final one is drive. What are the drives which we are using in the circular knitting machines are? So drives are generally classified into mechanical as well as the electrical. You can observe here the mechanical type of driving mechanism for the takedown and the fabric takeout, fabric wind up roller. So you can see here there are wheels which are present in the machine frame, and these are going to be connected to the takedown rollers and the cloth wind up rollers. So these two should be synchronous. If the fabric takedown and the cloth rollers are not synchronous, then there may be stretch in the fabric, so it leads to so many fabric defects in the further. So that is why it should be very synchronous. Now you can see this one, like the fabric is going to be passed through the takedown rollers and it is going to be wind into the cloth roller. That is general process of the fabric wind up mechanism. And you can see here the electronic or electrical type of mechanism where the motor is there, and through the motor the drive is going to be come, and the servo motors are going to be used. There are takedown rollers and cloth roller. Directly this motor is going to be driven. So whatever the amount of fabric is made from the knitting zone is going to be taken down and winding into the cloth roller. So this is general process of mechanical type of drive and the electrical type of drives. This session we have seen that what are the different components present, or what are the different mechanical elements or elements which are there in the single bed circular knitting machine. So single bed circular knitting machine consists of only one cylinder, one set of needles, one set of cams, one set of feeders. So these are the references, and you can refer these books for further information, more clarity. So till this I'm stopping the session. Thanks for listening. Bye. Thank you.